Imagine a time long ago before the age of modern science, in a dimly lit room, perhaps hidden away in a castle tower or a secluded workshop, where candles flicker, casting dancing shadows on the walls, and glass vessels bubble over gentle flames, releasing strange and mysterious vapors. This is the world of the alchemist, a world of experimentation and arcane knowledge, part philosopher, pondering the nature of existence, part mystic, delving into the secrets of the universe through symbols and rituals, part chemist, meticulously mixing and heating substances in pursuit of transformation. They were driven by a dream, a vision that consumed their waking hours and fueled their relentless efforts to find the philosopher's stone, a legendary substance whispered about in hushed tones, a substance said to grant immortality, to prolong life beyond its natural limits, and turn lead into gold, transmuting the base metal into the most precious of all. Their workshops brimmed with a chaotic assortment of tools and ingredients, peculiar powders, ground from rare minerals and exotic plants, colorful liquids, distilled and refined through painstaking processes, and the scent of burning herbs, a fragrant blend that filled the air with an aura of mystery and anticipation, a testament to their tireless experimentation, often stretching late into the night. Alchemists believed the universe held secrets, encoded in the stars and the elements themselves, and with the right knowledge, the correct combination of ingredients and techniques, they could unlock them. They pored over ancient texts, deciphering cryptic symbols and alchemical formulas, toiled day and night, fueled by the hope of a breakthrough, and saw each failed experiment as a lesson, not a defeat, a step closer to the ultimate discovery. The allure of creating gold promised a transformation, not just wealth but power and influence, but a profound understanding of nature's hidden workings, a mastery over the elements themselves. Their tools, alembics, crucibles, mortars, the instruments of their alchemical art seem primitive now compared to the sophisticated equipment of modern laboratories, but they were the cutting edge of their time, representing the pinnacle of scientific innovation. They experimented with a wide array of substances: sulfur, with its fiery properties, mercury, the elusive and transformative quicksilver, and countless other substances, each with its own unique properties and potential, always searching for signs they were closer to their goal, a glimmer of hope in the dusty labs. The transformation of lead into gold was not merely a practical objective, was more than riches. It was a symbol. It symbolized perfection and mastery over nature, the ability to elevate the mundane to the sublime. Though their quest ultimately failed to achieve its stated aims, their relentless pursuit, their meticulous observations, laid the groundwork for modern chemistry, paving the way for scientific advancements we benefit from today. The dream of turning the ordinary into the extraordinary, of unlocking the secrets of the universe, is a truly human endeavor, a driving force behind innovation and discovery that continues to shape our world. What is gold, really? Beyond its monetary value and aesthetic appeal, what truly defines this coveted element? Let's delve deeper and explore the science behind gold. To us, in our everyday experience, it's a beautiful, heavy, yellow metal, catching the light in a way that few other substances can. It's used for jewelry, adorning us with its radiant glow, a symbol of status and elegance. It has been used to mint coins, facilitating trade and commerce across civilizations. And it has been crafted into sacred objects, imbued with spiritual significance and revered in religious ceremonies. Its glow and resistance to tarnish have made it a symbol of wealth and permanence, a store of value that transcends generations. But to truly understand gold scientifically, we must zoom in, far beyond what the naked eye can perceive, to the atomic level. Everything around us, from the smallest grain of sand to the largest mountain, is made of atoms, the universe's fundamental building blocks. Each element, like hydrogen, oxygen, or gold, is uniquely defined by the specific type of atoms it contains. And gold, with its chemical symbol Au, is one of these fundamental elements, occupying a special place in the periodic table. A piece of pure gold, whether it's a nugget or a bar, is made of trillions upon trillions of identical gold atoms, all perfectly alike. So what is it that makes a gold atom unique, setting it apart from all other types of atoms in the universe? It all comes down to the nucleus at its very center. This nucleus is densely packed with positively charged particles called protons, and neutral particles known as neutrons, contributing to the atom's mass. The number of protons within the nucleus is what fundamentally defines the element, And for gold, that number is always 79. This specific atomic number, 79, is what gives gold its unique and characteristic properties, including its distinctive color, its remarkable malleability, allowing it to be hammered into incredibly thin sheets, and its exceptional resistance to corrosion, ensuring that it remains lustrous and untarnished for centuries. Furthermore, gold's unique electron arrangement makes it a great conductor of electricity, vital for many technological applications. And finally, it gives it that signature luster, that unmistakable gleam that has captivated humanity for millennia. So, gold is far more than just a mythic metal steeped in legend and lore. It's a specific atomic structure, a precise arrangement of subatomic particles, fundamentally defined by the presence of exactly 79 protons within its nucleus. That's the true essence of gold, its atomic fingerprint, the key to understanding its unique and enduring appeal. Elements are the universe's unique building blocks, like different colors of Lego bricks. Hydrogen, oxygen, iron, carbon, each is an element, each with its own kind of atom. The difference comes down to the number of protons in the nucleus. Scientists organized all elements into the periodic table, a cosmic recipe book. Each element's box shows its symbol, atomic number, and properties. There are 118 known elements, some natural, some made in labs. Gold's symbol is Au, and its atomic number is 79. That number is its core identity. 78 protons is platinum, 80 is mercury. A single proton changes everything: color, density, reactivity. The number of protons is like an element's DNA. Chemical reactions only rearrange electrons. The atoms themselves stay the same. To truly change one element into another, you must change the number of protons in the nucleus. Now we begin to understand why those dedicated alchemists of old could never quite achieve their ultimate goal: turning lead into gold. They toiled tirelessly, driven by a dream, but were fundamentally limited by their understanding of the universe. Their experiments, meticulously mixing different substances, carefully heating mixtures in crucibles over open flames, and patiently distilling their concoctions, were all, at their core, chemical reactions. These reactions only affected the electrons orbiting the atoms. Lead, as an element, is fundamentally defined by the fact that it has 82 protons residing within its nucleus. Gold, on the other hand, possesses a nucleus containing 79 protons. Therefore, no amount of mixing, no matter how precise, and no amount of chanting, no matter how fervent, could ever alter lead's fundamental atomic core. Chemical reactions, while powerful in their own right, can only form new compounds by rearranging existing atoms and molecules. But the atoms themselves, the very building blocks of matter, remain stubbornly unchanged throughout these processes. To truly grasp this concept, imagine an atom as a miniature solar system. The nucleus, dense and powerful, is analogous to the sun at the heart of our system, while the electrons, much smaller and lighter, are like planets orbiting around it. Chemical reactions, in this analogy, merely rearrange the planets, shifting them into new orbits and forming new configurations. But to fundamentally change the sun itself, to alter the nucleus and its composition, requires an entirely different level of energy, an immense force capable of manipulating the very fabric of matter. The alchemists, unknowingly, were working at the wrong level of reality, attempting to change an element's fundamental identity with tools and techniques that could only ever alter its surface properties. It's akin to trying to transform a cat into a dog simply by changing the color of its collar. The underlying essence remains unchanged. To truly transmute lead into gold, you would need to fundamentally alter the nucleus of each lead atom, specifically by removing 3 protons from its core. And that, as we now know, is not the realm of chemistry, but rather the domain of nuclear physics. The barrier that stood between the alchemists and their dream was invisible to them, a limitation of their understanding, but it was absolute nonetheless. The dream of transmutation wasn't dead. It just needed a new science. In the early 20th century, scientists discovered radioactivity and the secrets of the atomic nucleus. Some elements are naturally unstable. Their nuclei can change, transforming one element into another. Uranium, for example, decays into lead over time, nature's own alchemy. This showed the nucleus could be altered, but it required immense energy. The strong nuclear force binds protons and neutrons tightly together. To change the number of protons, you must add or remove them, something only possible with nuclear reactions. These reactions involve splitting heavy nuclei, fission, fusing light ones, fusion, or bombarding nuclei with particles. Modern physics replaced alchemy's potions with particle accelerators and reactors. Now, we could finally attempt what alchemists only dreamed of, changing one element into another. The age of nuclear alchemy had begun. So where does gold come from? Not from ordinary stars, but from cosmic cataclysms. Supernovae and neutron star collisions create the extreme conditions needed to forge gold. In these explosions, atomic nuclei capture neutrons, then transform into heavier elements like gold. Some of this gold was delivered to Earth by ancient asteroids. On Earth, we can't recreate supernovae, but we have particle accelerators. These machines smash particles into target atoms, sometimes knocking out or adding protons and neutrons. In 1919, Ernest Rutherford achieved the first artificial transmutation, turning nitrogen into oxygen. Today, scientists can create gold by bombarding mercury or bismuth with particles, changing their atomic structure. The process is deliberate, precise, and nothing like the alchemist's methods. We've learned to craft gold, atom by atom, in the lab. The alchemist's dream is technically possible. Modern science can make gold, but the process is astronomically expensive and energy-intensive. Particle accelerators and nuclear reactors cost billions to build and operate. The energy needed to change even a few atoms is immense. The gold produced is minuscule, just a few atoms or micrograms. Sometimes the gold is radioactive and unstable, decaying quickly. Producing a single gram this way costs far more than simply mining it. So, while it's a scientific marvel, it's not a path to riches. The alchemists wanted easy gold. Science offers a costly, microscopic version. Mining remains vastly more practical than making gold in a lab. The dream of easy riches remains out of reach. Here's a mind-bending fact. Most of Earth's original gold sank to the core when the planet formed. The gold we mine today arrived later, delivered by massive asteroid impacts. Every gold coin or ring is cosmic, born in stellar explosions carried by asteroids and deposited on Earth. When you hold gold, you're holding stardust from the universe's most violent events. Modern science lets us understand and even replicate element transmutation, but only on a tiny scale. We're bound by physics, energy, and economics, just like the universe itself. The alchemist's quest was based on a misunderstanding, but it led to profound discoveries. We didn't find the philosopher's stone, but we found nuclear physics. That's a greater treasure insight into the fabric of existence. The journey from myth to science is its own reward. The alchemist's desire for transformation sparked centuries of scientific inquiry. Their methods were flawed, but their curiosity led to the birth of modern science. We never found a magical recipe for gold, but we uncovered the secrets of the atom. We learned about protons, neutrons, and the forces that shape matter. We discovered how elements are forged in stars and cosmic collisions. This knowledge transformed our world, far beyond the alchemist's wildest dreams. The true treasure isn't artificial gold, it's the journey of discovery. Our understanding of the universe, from particles to galaxies, is the real alchemy. The quest to turn lead into gold led us to a richer understanding of the cosmos. That's the real magic, turning curiosity into knowledge and knowledge into wonder.